Welcome to C104, Best Practices for Live Streaming Production. Basically, it's actually part of that's wrong, so I should have updated that. But we have myself, who I work for Viacom, and I oversee a lot of the live streaming that happens there. In 2013, I was a Streaming Media Magazine All-Star, so I sort of know maybe what I'm talking about when it comes to live streaming. And we've got a great panel with people in some different industries doing live streaming. And so we're going to talk to you kind of about what our troubles are, where we see things going, how we do things, and then leave some time for all of you to ask questions. So hopefully we can help you guys solve some of the problems that you're having. So to get started, I'm going to let my panel introduce themselves. To start with,
so I'm Kieran Patel. I'm the senior.
I think, is your mic working?
I don't know. Is it working?
Doesn't sound like it.
Sound check.
Let's do a quick sound check with everybody.
Hey, 1, 2, hey.
Hello? No signal? Yeah. So, I'm Kieran Patel. I'm the senior product manager at BBC. I look after video media services. So that basically means I look after all of the live streaming that the BBC does. So that's the simulcast services that run 24/7 for all the broadcast channels, and the event streaming, so everything that sport did for the Olympics, any of the news event streams that run, and any music events, so things like Glastonbury that come out of the UK. All of the infrastructure, the control tools, and the distribution tools for that. And I also look after the VOD side of things for iPlayer to make sure that the long-form catch-up services that the BBC runs all do what they're supposed to.
Dennis Garner, live streaming producer, AWOL Huffington Post. Test, 1, 2, check, check, hey, hey.
Supposedly we're streaming this live right now online, so this would be a failure.
Test, here we go.
Live event. Sorry.
It's a good introduction to pitfalls of live streaming events.
Test before.
Number 1, test your mics before you start.
All right.
Dennis.
All right, Dennis Garner, live streaming producer, AWOL Huffington Post. I manage live streams for HuffPost Live. The contribution fees between our studios and on site provide best practices for whenever our brands have events on site. And I've been in live streaming production for over a decade doing events regardless of scale.
Simon, do you want to introduce yourself?
Yeah. Hi, I'm Simon Ball. I'm a global head of multimedia delivery and operations. I had to quickly turn my head there to remind myself. I'm actually one of my roles is the business owner of our audio and video streaming solutions that ties into our webcasting platform. Thank you.
So I think one of the really interesting things about this group of people is we basically have somebody that's on the broadcasting side of things with a digital property, a digital-only property, and then somebody that's actually servicing mostly corporate clients. So just to get started, I thought I would just ask our panel, kind of what's the most common workflow that you use for delivering live video? So I guess, Dennis, if you want to start.
Sure. Depending on local bandwidth or on site, well, actually, the biggest workflow we use is for HuffPost Live. It's where we transmit video over IP. So we like doing stuff over IP. And we have encoder-decoder pairs positioned at our studios in New York, DC, and LA. And they're transmitting H.264 transport streams back and forth over IP with forward error correction. They have ultra-low latency enabled, which enables us to communicate in real time back and forth, which is essential for our programming. We also occasionally have events or remote hits in the field where we send out a cellular muxing backpack called the LiveView LU70, and it transmits 4G cell muxing back to our facility in New York. Guests join our discussion via Google Hangout and Skype as well, and altogether gets encoded in our New York facility with Cisco and Elemental encoders, and published to Akamai with all the flavors, bit rates, and HLS, RTMP out to our connected devices that we support.
And Simon. since you are in a little bit of a different space, how about what you do?
So we deliver webcasting for corporate customers to target their important audiences, whether that's investor relations, corporate communications, or internal communications. And similar to the guys, is we traditionally used to backhaul a video signal back to an encoding center via fiber, satellite, or MPEG transport. And recently this year, in February, we released an entirely cloud-based solution, which we had built for ourselves by a company called Ideas and Arrays. And that uses MPEG transport stream from venue straight to a transcoding array in the cloud, which then converts it to Windows Media, Flash, HLS for mobile, and Android. We use a forward error correction that sits as a layer above that, which is currently from a company called Zitzi, to allow us to cope with data loss. So our ideal solution is to take a single encoder to location and stream out to the cloud. We still cater to audience, to customers that want to backhaul to us via video fiber or via satellite or via video conferencing. Increasingly, we're seeing the transition to MPEG transport stream from location. One of the considerations for a corporate customer is obviously cost. And so we found ourselves in the mid-2000s transitioning from satellite to video conferencing, which is not the kind of quality that we desired to deliver. And so replacing the MPEG workflow with the video conferencing workflow with the MPEG workflow was actually a very tidy fit in terms of keeping our workflow and operational and service process very similar. Sending a guy to site who's experienced, coordinates the production and the AV with either our own production partners or the customer's production partners, backhauls it to the cloud. We built an interface that allows us to access and control the cloud provisioning of streams, and allows us to switch it as well. And that's via web service. The whole thing is proprietary to our own design, and most importantly, fits the workflow that we use operationally globally to deliver webcasts for our customers.
Great. So I think that it's interesting to hear the trend of getting away from basically just doing fiber and satellite, transmission backhauls to your NOC, and then pushing directly to the CDN. There's kind of a lot of the term cloud being thrown in. Nowadays there's the Zen coders, the Wowzas, Unicorn Media, Uplink. There's kind of all these different cloud offerings. So I guess I'd just be curious to go around and hear, like Simon, what are you doing in your workflow that's kind of introducing the cloud?
So, my question for me, sorry.
Or just, I guess, expand a little bit, and then we'll come back across.
So we're using the cloud because of its elasticity and the ability to scale, and also because of our ability to give a high degree of resiliency into our workflow. So the great thing about a cloud is you can export an encoder in 2 different availability zones. You can split the signal to those 2 different availability zones and publish to 2 different geographically dispersed places on a CDN publishing point, and then from there use a playlist or XML to allow the player to automatically select the connected thing. So it gives us resiliency and elasticity. There is obviously a cost-saving benefit to build all of the tin for your busiest day. Is expensive, and in our use case, elasticity is particularly important because we have a very cyclical sort of role of event volume. So we could be doing 0, for 2 weeks in December, and 300 simultaneous audio and video events. In first Thursday in February, where we have a high volume of financial reporting going on.
And Dennis, I'm sure your situation's a little bit different, being delivering to a larger audience, seeing as I used to have your job. So how do you use the cloud nowadays?
Well, since we don't do many one-offs, I think it's a great tool to just, if you're a producer in the field and you're doing events on site all the time, it makes sense to use the cloud. But right now, we just source our video from IP or from on site, and we transmit it back to our facility that does all the transcoding and transmuxing and out to Akamai.
And when it comes to basically your IP transmission, what tools are you using right now?
Well, we'll send a Fujitsu out in the field, H.264 transcoder. That will, and we put Zixi underneath it or between it. So if we send a feeder and Fujitsu in the field, we'll transmit it over IP using that Zixi reliable transport. And there are a lot of things to keep in mind. There are, there's packet loss, there's latency, there's jitter that you can encounter, and so we use that service to kind of, use a reliable transport, and on our perceive end, on our decoder, we could just feed our encoders and our video router, the baseband video, and deliver it that way. So we could be essentially anywhere in the world, send an encoder out, and it will source our encoder on site, our facility in New York, where we do our segmenting and broadcasting and encoding.
And Kieran, how about you?
So we'll just touch on both points. So the transmission back, we've moved away from using RTMP straight to cloud and decided to put another box in between the RTMP encoder and the cloud, which actually writes all the chunks of video to disk and then goes HTTP straight from there. So we use then that source material as contribution for VOD workflows, and also with a little piece of software that puts manifests in front of those chunks as well. We can use it as a kind of contribution HLS for live encoders. So most of our 24/7 simulcast streams, we've got the kit that's going to be doing the baseband video to IP encode sitting with the same encoders that are producing the broadcast transmissions and providing source for all of the IP, VOD, and live workflows. The bits that we have in the cloud, because they're running 24/7, we don't get the benefits of the burst. We've got streams that we know are going to be running all the time. So what we're using the cloud for is ideally, because we've got that HTTP pullable source, we've got it as a redundancy, so we don't have to buy n plus n amounts of tin. We have enough resilience on premise, and then if one of them breaks, we know that we can spin up some cloud instances to cover the slack while the replacement arrives. And equally, our packaging layer, which does have to burst potentially, that's all cloud-based, so the encoders can stream to that, and we can put a cache in front of the packaging layer before the CDNs get to the content.
So also, since it sounds like a lot of you guys have different kinds of events, different environments, there's a lot of different ways to look at kind of redundancy and backup. And when it comes to live streaming, that's, I feel like, often more important than a typical VOD workflow, where if it doesn't work, it gets published later. Live streaming, if it doesn't work, people are coming to view your site at a certain time. There's an expectation that it's going to work then. And so there's a lot of different ways to look at it, be primary and backup encoders, primary backup networks for set encoders, QoS monitoring tools, backups of transmission paths. I'm just curious to kind of hear how you guys address redundancy and backup in your workflows. So I guess, Dennis, if you want to go first with the kind of digital only. Sure.
If we're doing something on site, it's good to have two redundant dedicated lines to feed our signal. We could have primary backup encoders either on site or in the facility if we're doing an IP backhaul, as well as at the CDN level. So if we have n+1 at the with our hardware, we can distribute out to CDN via primary and backup entry points, and then what makes sense is to if you're doing HLS streaming, to make sure you do the primary backup in there so it shows up in the playlist, and that's good redundancy there. And as well, if we're doing a backhaul on site, we could also, if we're connected, if we're connected to a whatever venue's Ethernet, we could use a cellular muxing backpack as redundancy, so we have two different kind of signals going back and forth, completely separate from each other, and it's a good tool to use.
Simon, on often, kind of smaller scale, but your own hardware that's built. How do you guys address redundancy?
So I think we sort of, our philosophy around resiliency and redundancy changed a lot of it to do with the cloud itself and how we could make the cloud function for us. So we expect that there's going to be errors, and expect there's going to be line drops, and expect that there is going to be failures, and embrace the fact that that's going to happen anyway, and then mitigate against it. So it's how quickly do you react to those errors, not how do you prevent them from happening in the first place, which is kind of a sort of turning your thinking around on that. And so auto-failing over as much as possible in the chain is critical to that sort of philosophy. Having that switch in the viewer's player that drops a disconnect. But there's a number of different issues that can be not auto-failover. Maybe it's to do with a rebuffering or a signal issue that's happening on the ingress, and that needs manual switchover. So having the tools that allow you to very easily manage that sort of monitoring and forced switch process is also important to the whole thing. I think our resiliency now, due to the way we've had our partners and developed in the cloud, is I think better than it's ever been because of this. You can use geographically dispersed signal paths, automatically. It's just automatically selected for you. So there's no conscious effort to think about your routing and your hardware and your tin. And that's the kind of the philosophy we've adopted.
I guess, Kieran, same question to you, and also if you do have any sort of QoS monitoring or the importance of that, if you could maybe touch on that as well.
So the model for the streams at the moment, we're in a kind of period of transition of moving over from old technology to new, but the primary and backup chains that we plug on to the end of kind of two different video paths to drive everything. But what our goal is to try and get away from the primary and backup, because it's saying it should be expecting failure, so we shouldn't have a primary that's the person that the users always get, and then the backup only when that fails. We're trying to get into more of an A and B leg scenario where the users can be watching either and even switching between them seamlessly, and then it doesn't matter if one fails and comes back later. It's no impact to the users. We can get on with fixing it. We just get alerted that we're maybe on a period of less resilience or less redundancy at any time. And from quality of service point of view, we've got kind of indications in our operations team that kind of look at and make sure that the end user is seeing something, because ideally any of that quality of service, if we get an alert there, we've not done our job earlier, because the user should always be seeing a valid stream. We've got more monitoring along our entire chain to make sure that if an encoder's gone down or if a package has gone down, end user monitoring shouldn't pick that up at all. That should all be good. Actually, we need to be monitoring the entire workflow and making sure that A and B legs are always working, and if one of them isn't working, we get alerted before any users find out about it.
And I guess I'll let any one of you jump in and take this question. I feel like each year, more and more devices are being introduced to the market that are, kind of having newer and newer specs as far as, what version of HLS they want, whether or not it even will take HLS or not, what the segment size should be. What are you guys doing when it comes to basically supporting new devices and old devices and making sure that everything works in your workflow?
In the past, it was tough to kind of deliver to every device in the ecosystem, because I think it was kind of fragmented how many codecs and delivery methods they all took. But now it's kind of easier because they all take H.264 and they almost all take HLS. But there are like complexities and compatibility issues with certain things, like certain smart TVs don't take certain HLS specs, and other devices they just have issues with certain codecs, and I'm trying to think of any other. There'd just be a.
Yeah, I think our problem is not what new devices there are, is continuing to support the old devices that are out there, particularly with browser versions. On the enterprise a lot of our customers, viewers, are accessing from their work. It's a work-orientated tool, and so therefore they're on enterprises. And there's still a surprising number of enterprises out there still using XP, for example. It's in the double-digit percentages of our audience. So it's doing the both for us that is really challenging. We're still supporting Windows Media, which I'm sure none of you guys are supporting.
We're trying to get out of it as
You're
quickly
still
as we can.
PVC, yeah, so
Yeah.
you've still got that legacy thing, but I'm sure you're not supporting
Not at all,
Windows
no.
Media or you guys. And so, I mean, that's a big challenge. I would love to drop. I would like to reduce the amount of formats that we support. I think new devices are less of an issue. Over the top is not something that I have any experience in, or do we need to do. So we're not targeting television devices. We're purely targeting mobile and desktop devices. Yeah.
So we've taken a different route. So we have the same issue. We're trying to get out of legacy formats, but we're trying to protect ourselves from kind of changes coming in the future by having our architecture have a packaging layer that sits before any of the CDNs. So we're not reliant on special services, and also we can adapt what our origin's providing. So if we're just keeping or producing from our live encoders the basic H.264 encodes that hit a packaging layer, then the requests coming into the packaging layer can be for HLS, can be for HDS, and on the fly it can produce it on a single request, and then we have a cache in front of that the CDNs can pull from. So that protects the amount of packages we need, and it also means that if we suddenly if we want to start producing Dash, or we decide that Smooth is the best way to deliver to Xbox, it's some configuration on that layer, not massive increase in encoder capacity or backfilling VOD even. It's just a case of making sure that we've got the configuration correct on the packaging layer, and then all user-facing products can then know that actually just ask for your VOD or for your live streams with this certain recipe, and you can suddenly get it all and get all of the existing streams in that way as well.
So outside of supporting new devices and kind of the I guess troubles of redundancy, what would you say your biggest roadblocks are, or when you're going to set up a live event, kind of the one thing that in the back of your mind is like, I hope this doesn't happen. This is what the pain point is, typically.
I guess the
Do you want to
first mile and last mile. It's always the biggest headache. First mile is connectivity. Venues rarely have fully redundant connectivity. Even if they claim they do, it's never diversely routed, so there's always the risk of that. And so we have to deliver, often we do compliance, regulated communications that have to work. There is no drop, so a very sort of rudimentary way of ensuring that you have backup is we'll create an audio stream out of a PSTN line as a backup to the video stream, because literally, you've only got one internet connectivity, or even if a venue says you've got two, it's the same one, just split somewhere in their infrastructure. And so yeah, first mile, big challenge, always gives me heartburn. And in our case, last mile, we touched on the enterprise. We have customers that have various configurations on their enterprise, and the challenge of ensuring that our stream gets through can be very big. Ideally, our customers warn us in advance that that's what they want to have happen, but occasionally they don't, and they expect 500 people on a 10 meg connection to view a high quality video stream and wonder why it doesn't work. Not so much anymore, but it does still happen.
Do either of you have anything additional to add?
Sure, especially on-site connectivity. I mean, we've seen in the past just, drop the stream way in the middle of the event, so it's good to have redundancy if you do go on-site, and just communicate with the IT department. Test your workflow way in advance. Plan ahead. Especially working with production, you may have a lot of audio issues. Let's say the audio engineer is making a full mix, and he's sending you a submix to your encoder, have him test the audio to you, so it doesn't come low or high in the gain. And again, IP over public networks. If you're not using any forward error correction or any service that reliably transmits the signal, it might have some issues.
I'd say the one crazy nightmare is the things not breaking properly. We've had a lot of testing we did before the Olympics was testing as many unhappy paths as we could of any of the components not working, and then the biggest failure we had was one of them not working quite as well as it should have done, and that's really difficult to test for. The network card doesn't break, it just starts behaving badly, or something along the line is slower. It's not just off, it's just slowed down. So potentially none of the alerting or none of the failovers kick in. It just is performing very badly, and trying to pick that up as quick as we can.
Yeah, I'd like to just add for anyone who is doing live events, if you are testing, beforehand, kind of the importance of actually testing in the environment that it's going to be on show day. Can't tell you the amount of times somebody, goes in somewhere, does a speed test, they set their encoder up, they test bars and tone the day before, not realizing that on the show day, it's not bars and tone, so their encoder is actually going to be pushing a lot more data. And also, there's going to be 50 photographers uploading photos, and that network connection that you thought was 30 megs is now like 2. Just definitely take that into consideration, because that happens, at least in my situations, more than I would like to admit. And I'm sure you guys have run into things like that all the time. So we're going to leave ample room for some questions, but I think the last question that I had for the whole panel was, if there's one tool or thing that you think would really help your day-to-day live streaming workflows, that would just make your job a lot easier, what would it be? So I guess, Kieran, do you want to start?
Yeah, so I think from my point of view, working very closely with the broadcast side of the industry, they work on a much slower refresh cycle. So next time it comes around, to make sure that they've got all of the IP delivery features in mind. So we're trying to get them to keep in mind that, for us, it's great to have timecode embedded into the video right from the start, to have SCSI markers embedded into video right from the start, and then we can make sure that's maintained throughout the whole chain, all the way to the player if we need to, and that gives us the flexibility to start doing either clever things on the server side or on the client side, and not be kind of restricted with how to come up with solutions. And ideally, then we can also have multiple chains producing identical output, because we can use the time code to synchronize everything, basically. When they come around to do the next refresh, to keep us in mind, and we get the benefits of the millions being spent on the kind of normal broadcast side of the chain.
Dennis, do you have anything you'd like to add? Or
I wish I could say. We already have it. It's Akamai QoS tools.
That's what I was going to say. That's what I would like. Well, not necessarily Akamai's, but multi-CDN. So definitely not just Akamai's. But multi-CDN and QoS tools would be something I would like to add. It's very expensive. The nature of the webcast, the type of webcasting we do, I don't think justifies the cost. But it would be great for our own intelligence to get more data on consumption.
Yeah.
So I'll take a moment if anybody has any questions, we would love to kind of be able to help you guys with what your problems are. So if you do have a question, I think you actually have to come to this mic that's in the middle of the room so they can hear it for their recording.
Actually, I think I have one of those voices that will carry.
I can hear you.
Yeah, you do.
I was curious, I'm not sure about the nature of the content that you serve, but do you require security when you're in the cloud, and if so, what type of security method do you have?
So when the content's in the cloud, it's being live streamed, so it's pretty much in public domain. And so we don't need security around the stream, and anything that exists in the cloud is the stream itself. But we do get requests to add more security layers to special cases for our customers. So we can do all of the standard stuff: IP restriction, hashtag authentication, single sign-on, all of the sort of custom implementations that secure a series of events for a customer. The webcast platform itself is obviously it's in a data center, and being part of the NASDAQ, we're very security and compliance conscious, and so we've gone through all of the security rigors that you would expect an organization to go through, code scans and penetration tests and audits and everything. So the application that serves the player and the content that sits around the player, like the PowerPoint presentation, is not in the cloud currently. It is in a secured data center environment.
I guess what I was getting at is that, these days you could use things like DRM or play-ready DRM and
Yeah.
these kinds of things that provide licensing and encryption services. And I was just wondering.
No, typically our customers don't have the call for that, for the digital rights management system. The most complex security we tend to do get requested to do is an SSO, Active Directory integration, which only allows access for an enterprise portal, or maybe a hashtag authentication or token authentication.
I just have one more question.
Sure.
Since you deal with enterprises, so how do you deal with congested networks in a network?
Have we got time?
Since the world doesn't operate so well.
So it's a huge question, because every use case is very different. So congestion could be a variety of different issues and have a variety of different solutions. In an ideal scenario, a customer has a proxy set up that we can stream split or cache through, and we'll serve a specific stream to them that enables them to do that. It has to be preempted. The request has to come in, and then we'll custom the delivery of that particular event for that customer according to their network. But they may even have their own peer-to-peer technology internally, in which case we'll interface with that and provide a stream to that. But there is no single solution for all of the variety of different enterprise problems that exist. The solution could be as simple as get people into rooms and don't have them all watch on their desktop. That's the cheapest one for you guys, and we know that you're only going to be able to stream 30 streams, so pick your rooms and make them big and have them all sit in there, through to something much more complicated.
Are there any other questions from? Yeah, feel free to come up.
So you, Dennis, isn't it? You mentioned using the LU70 and other CellMux kit. I just wondered, across the three of you, how much you've been using that kit as a primary backhaul technology in the field, whether it's actually going to become established as a primary technology, or whether it's always going to be a backup technology.
We use it primarily as well. I mean, it's very efficient. These bags have like up to 15 modem cards placed inside the backpack, and they each have different cell services. So it's like Verizon, AT&T, and Sprint, or whoever else, and it kind of has a built-in redundancy. So it kind of dynamically switches to whatever has the best cell service in that area you're in, and we've used it a lot on site, especially when we do ENG in the field. We're transmitting back to our facility. And even it's good because it has low latency as well, so you could use it in real time to be part of programming. We also use it for backup, redundancy as well. But the best situation we had to use the live view was we were at CES, and we were at the Las Vegas Convention Center, just walking around with literally thousands of people, just bumping into each other, all on their cell phones, and you'd think it would be competing with this service, but it dropped out maybe twice out of the 4 days or 3 days that we were shooting, with a roaming camera kit, and I think it's going to be out of all the methods of bringing video in IP these days, other than like fiber and satellite. I think the portable live view LU70s or the Teradx, the Cerevo shell, you're going to see more of that.
Any other questions, or do actually, Karan, do you use those?
We haven't done. I think we used it, or our news department used it for some of the torch relay coverage, but I think they hit the same issue. They drove the entire route, and then were going to use it on the opening day where exactly everyone else was using their mobile phones and taking pictures, and it wasn't getting any signal out. So the opening of the torch relay, we had to go back to the satellite and didn't get any coverage from live. But so we tend to we kind of hand that problem over to the broadcast side, because if it's important enough to want video for, they'll probably want it on one of the news channels. So we make sure that they've got a way of getting the video back, and as soon as they've got the video back, we can piggyback across it and start using it to do live streaming on as well.
My question is with regards to redundancy. You spoke about redundancy before, about maybe one camera, two encoders, two transporters all the way down. How far in your architecture, across all three of you, do you do redundant streams? Do you do all the way up to 2 feet client-side switching, or are you doing, one edge and you have some sort of VRRP, HSRP just before it? What are the methods you use for redundancy?
Shall I take that first?
Sure.
It really depends on the use case and the customer's desire in our case. Ideally, we have the ideal setup would be diversely routed internet connection with 2 encoders. Those encoders point to different receivers in different cloud locations, which go to different transcoders, which get published twice to different CDN ingress points, and then it's resolved at the player side at a playlist. And that's the sort of nirvana of
That's in an RTMP scenario, I'm sorry.
It's a MPEG. We use MPEG transport from site. We don't do RTMP straight from site.
So your delivery is HLS?
Our delivery is transcoded to Windows Media HLS and RTMP H.264.
So in terms of HLS, you'll have 2 independent origins?
We publish to, oh, he can answer the question, he built it.
So the client making the decision to switch to another origin if one is failing? So it's client-side switching? Okay.
Yeah, it's a playlist or an XML.
So basically, the further down you push that decision to it seems the client-side switching is where it's going, but a lot of clients today don't do it unless you have some homegrown app added to it. There can be some challenges, especially in
Yeah, well, we wrap in our own player, so it has the player functionality has the playlist. In fact, I think it's on the diagram. I can show you afterwards.
Yeah, absolutely.
And I guess Dennis or Karan, do either of you
So we kind of do it a slightly different way. We have basically the same model when it comes to CDN redundancy. So you'd have to get another manifest if you wanted to switch from CDN 1 to CDN 2. But everything back from our kind of caching layer backwards should be invisible. So they could get a manifest from one leg, the video from another leg, and then the next chunk of video from the first leg again, and it should be seamless. They can switch between the two because we've synchronized both legs. But if the CDN has trouble and they've managed to fail across or couldn't get a connection on one CDN, it would then be a reconnection to try and get the top level manifest again from the alternate CDN.
Do you have anything to add, Dennis? Or
We have one CDN, so we don't have the client-side switching. I mean, I know that Conviva helps out with that if you have dual CDNs. But in terms of redundancy on the hardware, we use 2 encoders, especially in our IP transport from our studios back and forth, and the N+1 with the encoders, and to the publishing points in our CDN.
Can I ask you the available solution you use for encoders manager?
Well, if one goes down, just that we're delivering to the backup entry point, and that's referenced in the player via HLS or HDS flash.
any other questions? Anywhere? That's easy. Well, if there's no other questions, thank you guys for coming. And I think there's like a coffee break next or something I'm supposed to tell you about. So.